Hey everybody, this is Matt with MathMath.com. Thanks for joining us here today as we talk about solving quadratics. How do we solve quadratic equations? How do we find the x-intercepts of a quadratic equation? Let's do that. All right, we're in the Common Core Math Standard of the number system, and we are going to be working with various degrees of polynomials today, especially quadratic equations. All right, so we're going to learn how to solve quadratic equations, simply that. All right, now, with a quadratic equation, you got to remember that it's going to look something like a parabola. Okay, it's going to be this curved shape like this. All right, and what I want you to think about is how this relates to physics and science. With quadratic equations, we really will use this a lot to solve motion of objects in the air as they fall. Imagine this was an object that was thrown in the air. It goes up and then falls down at a particular speed, as well as lands at a particular distance or time from where we were. Okay, so let's do that. Here's the equation of how you find out how high an object will be once you throw it. Okay, so got to have a whole bunch of variables in here. All right, each of these represents a specific thing, and let's talk about what they are. Okay, S is the final distance in feet after t amount of time. Okay, in seconds. S is the distance of where an object will be after t amount of time with initial velocity of v naught, v with a little zero, v naught, and initial height of s naught. So s represents the height, s naught represents the initial height. So if you're 6 feet tall, you throw the object in the air, you'd put a 6 there. And where is it going to be? Where's the object going to be after a specific amount of time? Okay, so that's what we're looking at today. Pretty cool. Let's think about it this way. You're standing on a mountain that's 300 feet high, and you throw a rock that's 52 feet per second in the air and wait 3 seconds. How high will that rock be at that time? Well, we plug everything in the equation. We know our initial speed is 52 feet per second. We know that we wait 3 seconds. We know that we throw it at an initial height of 300. We plug all those things in, and that will give us the final distance of what we're looking for. So it's going to be 3, because we waited 3 seconds. That's our time. T's there and T is there. 52 is our speed that we threw it. Negative 16, that's gravity. That's the force of gravity on the equation. It's the rock. You square it. 300 again is how high you're throwing it. Now, all you got to do is solve for this, add all those up together. Bam, and you get 312 feet. So after 3 seconds, it'll be 312 feet in the air. Isn't that cool? That's really powerful to be able to say, hey, I've got a math equation. I'm going to plug a few numbers in, and bam, I know exactly where that rock is at a specific time. Pretty sweet. All right, so let's talk a little bit more about quadratic equations and how we can find them, okay? First of all, let's define what a quadratic equation is. All right, it's an equation that can be written in this form. 0 equals a times x squared plus b times x plus c. Okay? Simple as that. A is the number in front of x squared, b is the number in front of x, and then c is that loner guy over there on the end. All right, so let's talk about it. You know what? Once a car decides to stop, it travels a certain distance. And the formula for how much and how far it will have to stop is this, where d is the distance it takes for this car to stop. S is the speed it was traveling in miles per hour. Okay, so this is a quadratic equation. We have d is the distance it takes to stop, and s is the speed it was traveling in miles per hour in order for it to stop. And it will tell us, when we plug everything in, how far it had to stop. All right, so here's our equation, and what we're going to talk about is, let's say, hey, your car is 15 feet long, and you know what? The safe traveling distance is about 4 car lengths in between you and the car ahead of you. So you don't want to be traveling too fast, all right? So we need to at least have that distance of 4 car lengths of 15 feet in front of us. We need to know how fast we'd be traveling in order to be able to still stop just before we hit the other car in front of us if it comes to a complete stop, okay? So 4 car lengths. Our car is 15 feet, so that's going to be 4 times 15. That's 60. Now we're going to solve for S. We subtract it there, subtract it from the other side, and now, look, we've got a quadratic formula. 0 equals 5/100 s squared plus s minus 60. We've got a quadratic equation. All right, we've just turned it into a quadratic formula equation. All right, so let's just take that scenario for example. How fast, what's the fastest you could be driving in order to not hit the car in front of you if you are those 4 car lengths behind you? All right, so now what we're going to do is we're going to graph this equation. And what I want you to do is to go back to that original formula that you wrote down just a minute ago with the s squared and the 60. And I want you to plug in for x. I want to plug in these values. I want you to start around negative 50. And I want you to go all the way up to 40. And I want you to plug the negative 50 in and see what spits out for y. Then I want you to plug a negative 40 in and see what spits out for y again. Same thing for each of these guys. That will give you dots on the graph, and he will be able to help you graph this parabola over a specific period of time, and you'll be able to tell where it hits the y-axis and where it hits the y-axis over there, okay? By plotting those points, you can get a good idea of what that parabola will look like, especially when it's something nasty like 5/100 times s squared. Okay, so instead of s, that's going to be your x, and then it's going to spit out your y. Okay, your s is going to be your x there, and it's going to look something like this. Your x-intercepts are going to be around 47 and negative 26 miles per hour. Now, if you think about it, you can't be having negative 26. You got to have 47. So most likely it's going to be 47. Okay. So let's just talk, just in general, how we solve for quadratics. We're going to write the equation in this form. 0 equals ax squared plus bx plus c. And then you're going to find the x-intercepts. Okay, that's how you solve a quadratic equation. Let's do that. Would you find the x-intercepts here? First, you got to move the 10 over. That's going to leave you with 0 over there. And then what I would suggest is that you plug in some values for x. Start with maybe 5, and then go down to negative 5, and see if you can find where it hits the x-intercept, just by plugging some numbers in. All right, what'd you get? Did you get that was 5 and negative 2? Yeah, plug in those numbers in. That will really help you. All right. Now, let's talk about the quadratic formula. Now, of course, there's an easier way, just like there always is, all right? Plotting it and then putting it on a graph and then trying to find the x-intercepts can be a little bit daunting. But there's this formula called the quadratic formula that we can use to easily find the x-intercepts, and it's this, where b is, again, that number in front of the x, a is the number in front of the x squared, c, there's only one instance of it, is that number that's tagged along on the end, okay? If you're not familiar with this plus and the minus, that means you're going to be having two answers. Just like in any parabola, you've got two x-intercepts. For most of them, you'll have two answers here. Okay, you'll take this, then you'll add this, and then you take this, and then you subtract this, and that'll give you two answers. Anybody recognize this? You know what this is? You remember what this is? What's that formula for? If you said line of symmetry, that's it. Okay, this is the line of symmetry. So you start off with the line of symmetry, and then you're going to add and subtract this whole thing. Now this all still follows PEMDAS, okay? Don't let this trick you. Don't let it make it look so bad, all right? You're just plugging in some numbers here and solving it with PEMDAS. This is the distance right and left of that line of symmetry, okay? So you take all of these numbers, plug it in together, and that's the distance to the left of the line of symmetry and to the right of the line of symmetry in order to find it where it hits the x-axis, okay? So that's what you're going to be doing. So with our new equation, let's find the exact x-intercepts in speeds with this equation. Plugging all their numbers in. Our a is 5/100 times 2. Our b is 1. Bam, plugging all the right numbers in. Those minuses, again, become negatives, okay? And then you find that you get this. Negative 10 plus or minus the square root of 13 over 1/10. Now, I want you to solve for all of these, okay? You're actually going to take the square root of 13 divided by 0.1, and then you're going to take negative 10. You're going to add that number. You can take negative 10 and subtract that number, okay? And you're going to get something like this. X equals 46.06 and negative 26.06. All right, so your speed is going to be 46 miles an hour. That's what happens there. So again, you can't have negative 26 miles an hour, so it's going to be 46, and that's your answer. All right, so there's two different ways. You can factor it and find the x-intercepts that way, and the quadratic formula. I would recommend, if you can factor it, do it that way, right? That seems to be the much quicker way. Whereas the quadratic formula, you got to do a whole bunch of square roots and squares and subtracting and adding and all that kind of stuff. Quadratic formula sometimes will be easier, but most of the time factoring is going to be, okay? There's two different ways. You have two different options. If the numbers are pretty tricky, like the last one was, use the quadratic formula. All right, determine which method to use. Find the x-intercepts. Is it easier to do the factoring method or the quadratic formula? Factoring method or quadratic formula? Factoring method or quadratic formula? Basically, you just figure out, can you factor it? Is it easier? All right, so here are your answers if you need some help. Quadratic formula on the first one, because you started off with negative x. That's super difficult. Second one, you could just factor it easily to x minus 7 and x plus 2. So then this is positive 7 and negative 2. Your quadratic formula on the next one, and it's going to be negative 1/3 and 1. Well, what do you think about this quadratic formula? Pretty easy, huh? You're just really plugging numbers in to solve it, and that's it. So we're using quadratic equations today. Thanks for joining us. I bet you learned a lot. And now we're really able to get into all of these cool scientific stuff. How far, how long does a ball take to hit the ground? How high do you throw it? Pretty neat, huh? Just all with math. Pretty cool. Well, this was Matt with mathsmath.com. Thanks for joining us. Check us out on Facebook at Solving Maths Problems and on Twitter, Maths Math, and enjoy math.